Without further ado, I'd like to introduce our first presentation. We're going to hear from Natan Shachar. Natan, again, an entrepreneur with business experience from New York all the way over to Samaria. Natan is going to tell us a little bit about an innovative project, which I think you'll all be very excited to hear.
Good morning, good afternoon, good evening. Thank you, all of you, so much for the opportunity. It's an honor to be here. I'm here today. I'm the CEO and founder of Shachar Ltd. We're bridging the combustion and renewable energy economy. And really the reason why I'm here is because my customers have a problem and they've asked me to solve it. My day job when I'm not building startups is I run an engineering consulting business in New York City for the past 10 years. I moved to Israel 4 years ago. And I serve more than 1,000 property owners in New York City. And they have a big problem. The laws that have recently been passed put a price on carbon dioxide emissions that is so high that many of them are risking going completely under. Business as normal is over for them. And as their engineer, they came to me and they said, solve our problem. And upon looking at it, I saw that without technological innovation, there was no solution to their problem. So it was in answer to that problem that this business emerged. I've been 33 years old, been working for the past 10 years, as I said, running an engineering business in New York City. I earned my master's and bachelor's degrees in environmental engineering at Columbia University. My co-founder and chief technology officer is Professor Gadi Golan. He has more than 40 years of experience in academia and in startups, bringing ideas from the concept stage into reality. Sorry, somebody's motioning where the camera is. Thank you. From the concept stage into reality, more than 15 patents and 100 publications. He's currently a professor of electrical engineering at Ariel University and previously served as the president of the Holon Institute of Technology. So the problem that we're solving here is the clean energy crisis. The clean energy crisis really boils down to two main issues. One, you have the issue of carbon dioxide, and number two, you have the issue of renewable energy. Carbon dioxide emissions, following on the Paris Climate Agreement, are being taxed all around the world increasingly at rates that make business as normal completely untenable, whether it's transportation, manufacturing, energy, real estate, agriculture, it doesn't matter. Business as normal is over. And the challenge is the existing technology to deal with carbon dioxide emissions is linear, it's costly, and it's not a compliant solution. It simply won't work. The other side of the clean energy crisis is renewable energy. You can't order sunshine, you can't order wind, and so as a result, renewable energy is so volatile, is so chaotic. There are even many markets where they pay customers to take surplus electricity because they simply have more power than they know what to do with, and it's a problem on the grid. Lithium-ion batteries, the storage solution that many think might help deal with this, simply do not have the capacity to deal with the issue, and they're currently failing to balance out the grid from renewable energy sources. It's precisely because of this problem that clean energy, on the one hand, is not able to meet the needs of the global economy, and on the other hand, the cost of carbon dioxide emissions from combustion is now being taxed so high that customers are seeking me out. Whether it is the New York City property owners that I deal with on a daily basis, whether it is gas utilities. I just spoke the other day with People's Natural Gas in Pittsburgh, Pennsylvania, and they're extremely excited about the solution. Many customers are saying, we have this problem, please solve it. Our solution relies on the technological breakthrough of a zero-emission closed loop. What we do is we have the Shachar module. In comes carbon dioxide, in comes renewable electricity when it's available. We then use that renewable electricity to reprocess that carbon dioxide back into natural gas. Now, natural gas has 100 times the energy density of a lithium-ion battery. So it is something that can be stored and used when needed. It gives the ability to truly balance out the grid. Now, what our system does is it can work on that start-stop nature of renewable energy. So even though electricity from renewable sources is only available part of the time, it doesn't matter. We take it when it's available, we process the carbon dioxide back to natural gas. Natural gas, in turn, can be stored and used when needed. Our IP is built around the intermittency of our process. So because renewable energy is intermittent, all of the chemical processes that are necessary for us to convert carbon dioxide into natural gas must run on a start-stop basis. It is not trivial. There's an enormous amount of innovation that goes into it. We filed patents in the United States and the European Union, and we have a whole family of further IP being filed under that as things progress. Our technological foundation is built on a tech transfer agreement already in place with Ariel University in Samaria. We're the recipient of a 500,000 shekel matching grant from the Israeli Ministry of Energy. We already have a fully operational lab-scale prototype and letters of intent to implement our solution with known companies, including the Israeli Electric Corporation and Hewlett-Packard. Our focus right now is accelerating our commercial development. We have a 500,000 euro matching grant from the European Union that starts being dispersed in January 2021. We have an established customer base in New York City. We have pilots in the pipeline with the People's Gas utility in Pittsburgh, Pennsylvania. And we are currently looking to finish our shipping container-sized prototype, which is under construction in January 2021. The market opportunity here is more than $6 trillion, with multiple, which is spent on the combustion economy annually, with multiple sub-verticals there, whether it's biogas or the New York City real estate market or natural gas utilities. There are many early adopters that are extremely interested in what we bring to the table. At this point, we will have a fully operational shipping container-sized commercial prototype operational by January 2021. We'll be deploying multiple pilot projects in Israel and the United States over the year, and by 2022, we expect to be fully in the market with a commercial product. The financial plan at this point is to raise $225,000 to do two things. Number one, we want to finance all of the software development with our Palestinian development partner, Radix Technologies, based in Nablus and led by my good friend Adel Jodala, who Avi introduced me to. And they will be covering all of the software development of our project. We also are looking to accelerate the development of our technology so that we can be in the market faster and move what would normally take 8 months to take 3 months. I just want to finish by summarizing. I've discussed this business with many different types of organizations, whether it's government organizations or potential customers, utilities, and everybody I speak to basically responds the same way. They say, well, I need it tomorrow. When can you deploy it? This is a solution to a problem that already exists, and we're very excited for you to join us in this journey.
Thank you very much, Natan. It's pretty amazing, actually, to think that with this research process that, again, relatively short runway, when you think about it, you've come very, very far, and you're really on the cusp of these upcoming opportunities. We want to see if our community here, the IBR community, which is alive, well, and growing, wants to get involved in your project. And so, Mike Humphrey, I'm going to turn this over to you with the first question. And then anyone else, again, if you have questions for Natan, now's the time to send those questions in the chat, and we'll see what we can pick out, whatever we'll have enough time for. Mike.
Natan, well done. Love that presentation. And before we get started, it's my honor to introduce everyone on the call to our friend Chuck Bentley, the CEO of the Christian Economic Forum. And Chuck and I are honored today at this first inaugural showcase to be your inaugural sharks. So welcome, Chuck. And one more thing, I'd love the compelling, ethic of the Christian Economic Forum about convening the world's top problem solvers to advance God-inspired solutions. And I say that because I sense that's the mission we're on together. And so, Chuck, welcome.
Thank you, Mike. Natan, congratulations on what you've achieved so far. It is very exciting to see the breakthrough development that you've created. And I could ask you 1,000 questions myself, but just to save time, tell me a little bit about the grant from the European Union. How did you acquire that, and what's their criteria for product development? It seems like the urgency is to get to the product stage sooner than later.
Yes, okay. So the European Union has a program called the Horizon 2020, where they fund development projects that are multinational across the European Union, along with neighboring countries, including Israel, every year. So we applied as part of a consortium of companies and universities across Europe that includes us to develop a energy storage technology for electric vehicles. Basically, what they want is they want to use our power to natural gas solution to create nodes for providing very dispatchable power for electric vehicles spread across a grid that can't handle the high volume of electricity that would be required if everybody had an electric car. They have a long process in terms of reviewing the group as a whole and then each individual company to meet their criteria, and it's a matching grant. So for every dollar that we spend, they match that by $1. And there's a specific scope of work for the group and then us individually in that context for achieving the research goal, the innovation goal. So that's the background.
Thank you, Chuck.
Yeah, thank you, Natan.
And thank you, Natan. Sorry, was that Mike? Mike, were you chiming in there?
Yeah, let me chime in this way, Avi. Natan, one of the things I wonderfully see on my screen that you can't is we already have 8 questions, which is amazing. Okay, one of which is a question that Chuck and I have been talking about, which is about the breakthrough technology, and if you will, in our language, your secret sauce. And will you talk a little bit more about, this novel solution? Because I quickly want to move on to some of the other questions relating to early adopters. Where's this going to be? Where are we going to sell our first commercial products? But before we start that, would you talk a bit more about what is the technology breakthrough? What is the secret sauce that are compelling these people to seek you out?
Yes, with pleasure. Okay.
And Natan, sorry for being the guy with the stopwatch and the people in production in my ear, but unfortunately, just for this particular segment, we've only got about another 3.5 minutes. So if you could try to address that question quickly, we'll see if we have time to slide in another. If not, we'll just dedicate it to this question.
We'll do a full course of chemical engineering in 15 seconds, no
Perfect.
problem. There are 3 core processes in my technology. There's the separation of exhaust gases, carbon dioxide, water, and nitrogen from each other, the primary components of combustion exhaust. There is electrolysis, converting water into hydrogen, and then there's the combination of hydrogen and carbon dioxide together to form methane, which is natural gas. Now, all of these processes, if they're done on a constant basis, no problem. We know how to do that. The secret sauce is in not just integrating those 3 processes together, but making it so that all those processes can stop and start on a dime in sync with electricity markets. Because spot electricity markets, electricity is sold on a 5-minute interval. That means we need to have an electrolysis machine that can start up and shut down in 5 minutes. We need to be able to separate carbon dioxide from these other components. We need to be able to keep a methanation reactor for combining carbon dioxide and hydrogen together to produce methane. All of these things need to be built in such a way that they can interact with an electricity market that where only when the price goes low because there's surplus electricity do we operate our system. So I don't know if that answers the question. There's a lot of material behind there, but I'd be happy to go into detail, I guess, offline after this.
Thank you, Natan. And on that point, before we start moving already to our second team, Natan's point here is critical. This conversation doesn't end today. This conversation begins today. Yes, we're talking about 1 million shekel in investment now, today. We'll come to some decisions in the coming days based upon today's presentations. But as both of our presenters are well aware, IBR is committed to their success, and each and every one of you, our guests, you have an opportunity to continue to engage with these companies beyond today's event. One quick 15-second question, and then we're going to have to close this part of our session for today. Thank you, Natan. Question that came in right at the top. Are there any other competitors in this space, competitors that are further along in this process of providing some sort of solution that addresses this same market challenge?
To an extent. There's no other company that's doing exactly what they're doing. There are many utility-scale power-to-gas plants in the European Union that are fully operational, but they do not have the modular approach that we take, and they're much less flexible in how they operate. So it's really a customized solution, one-off, on the utility scale. It's not something that can be used for a commercial scale boiler or a small installation. There is one company in Germany, Exitron, which has a more modular product, but it is only designed for new construction type installations. It does not have the ability to retrofit onto an existing combustion appliance, so it's severely limited in terms of where it can be deployed. A big element of what we've designed from the beginning is to adapt to my hands-on experience where I come from in the New York City boiler world, in the world of actual hands-on projects. So from the beginning, we've designed around retrofits of existing commercial scale applications. No one else is doing that.
Natan, thank you so much. This is fascinating, very exciting. There's 2 points I have to make as we let you step off stage. Point number one, I want all of our guests to understand the time that we've given to Natan is an impossible time frame, both to present and then to be able to address the questions that keep coming in. Keep the questions coming. We're going to be able to connect you with Natan after this event, but just understand the circumstances are impossible. Natan, thank you for being such a great sport about that. Point number two, because we put him in the pressure cooker of time, Natan didn't have an opportunity to talk about his integrated business partner who is unavailable to visit with us or present with us today. And the reason is simple. You heard it from General Krulak at the top of this presentation. Not everyone, because of some of the, let's call it societal pressure, is allowed to be public about their partnerships with Israelis. And so the partnership that Natan has with the software development company that develops a core technology for what it is that you've seen with all of what Natan is explaining is unavailable to be here on stage. It's unfortunate. It's part of where we're moving the needle, but it's also part of the business model, the integrated business model that Natan has been sharing with us. Natan, thank you so much. Thanks. We're going to continue to be in touch. We'll keep you posted.
Okay.
And we're going to hand this over to our next presenters.